Well, thank you. I'm actually not the one who came up with the slides, but I'm assigned to talk about it. ARM joined the OCP as a platinum member only last year. So this is a new experience for us. We are beginning to participate quite a bit. OpenEDGE certainly is one of the reasons that we joined, because we noticed that some of the specifications that people are working on refer only to one of the architectures, and we want to make sure our architecture is also covered. So the OpenEDGE project creates the specification standards and support document reference designs would enable global adoptions of OpenEDGE compute chassis, and which would meet the requirements of telco providers, right? So the project itself is releasing a lot of specifications in OpenEDGE chassis, and also covers, well, the intent is to be CPU ISA agnostic, and that's primarily the reason, ARM has joined the effort, and we are joining with our partners as well. Because ARM itself doesn't actually produce a chip, right? I mean, the SoCs are actually produced by our partners. So we want to make sure that the architecture is capable of supporting what we're doing. And so there are specifications that are under community review, the OpenEDGE server specification, currently referencing the Purley platform, and we would like to enable the ARM-based servers as well. But before we get to the OpenEDGE itself, we have also been involved in a lot of the other Edge-related efforts. So the Linux Foundation Edge, which is unifying the open source Edge development from IoT, telco, cloud, and enterprises. Right? So we have joined the Linux Foundation Edge effort starting earlier this year, and the momentum continues. And one of the areas that we are trying to help look at is that the industry IoT today is pretty much a vertical stack, right? So all the way from the IoT asset to the cloud, you have these big giants working on the solutions, but they are pretty much vertical, right? And with the Linux Foundation Edge effort, there's at least an attempt to define the open APIs that could basically make all the IoT assets work with any of those cloud infrastructure together. So also within the scope of the Linux Foundation Edge, there is this effort called the Akraino Edge Stack. It covers the portion that I think is very much closer to the data center, and the applications and network provisioning and orchestration, right? So it covers the spaces like telco, cloud, edge, on-prem data center edge, modular data center designs, edge as well, and industrial and telco radio edge, all the way kind of getting to the space where the gateway is at. So this is kind of a pretty wide range of devices that are potentially possible. And then you get to the devices that are closer to the IoT devices, the device edge, where maybe the Zephyr OS would be usable for a lot of the IoT devices. So this is kind of a very wide range of edge possibilities that we are looking into. And specifically in the discussions that we have for today, we're kind of focusing on one area of the what they call the blueprint, the Akraino R1 blueprint, which is focusing on the radio edge cloud. And so this picture is basically the whole stack from the hardware all the way to the software support. So the telco grade edge cloud platforms are the focus here, and we take a look at how we can use the ARM architecture to support this this purpose, right? And we look at the telco appliance blueprint, and the radio edge cloud blueprints. Blueprint is a member of the telco appliance blueprint family, which is designed to provide a fully integration tested appliance tuned to meet the requirements of what's called a RAN intelligent controller, the radio access network, right? And then this usage case for the radio edge cloud basically specifies these kind of requirements, and we noticed that it is using this x86 OCP OpenEDGE server specification, and so that kind of got us motivated, and we want to work with our partners to enable the OpenEDGE servers. So operators are proposing new features for OCP OpenEDGE. Also work on multiple instruction set architecture, including ARM, powered by ARM ecosystem partners. And so in this talk, I'm going to point to a few cases where our partners are working with us, specifically Ampere, Broadcom, and Marvell. So in terms of Ampere, actually there is going to be a session after mine where Shannon is going to probably provide some more details, but I'm going to kind of just run through a little bit. Why Ampere at the edge? Because they are defining the scalable, powerful, efficient, supported, and reliable systems, right? They have the 8 to 32 core SoCs with 8 memory channels and 42 lanes PCIe. And the core is pretty powerful, large, high performance. And it supports the Linux, Windows, hypervisors, and all the environment that people expect and such. And this is the platform specification. So it's quite a lot of details, but the form factors is following the specification that the OpenEDGE has defined. And I think you can probably, the slides are going to be available, right, on the web, so you can dive deeper into, all these details about what the processor, memory, I/O, power, performance are looking like. Availability is in Q4 of 19, so it's pretty soon for the samples. And it fits right into that chassis that everybody is familiar with now. Okay, so next is the Marvell proposal with Thunder X2. Thunder X2 is a SoC that's being used in a lot of the ARM servers based on Marvell chip. So again, it's using the similar form factor that people are familiar with. And then the specification on the right provides you with the details on what the system's looking like. Again, it's similarly, processor, memory, I/O, BMC, storage, and such, right? So again, the slides are going to be available, and if you're interested, you can take a look. And I wonder, when this is all said and done, it probably would be integrated into some of our specs, right? So, Purley is one example. Now we have 2 more examples. Okay, and so Broadcom also has been doing this thing called SmartNick. Everybody is interested. So Stingray is their project for that SmartNick, and they also intend to have the support with OpenEDGE. And so this is what the Stingray chip and the PCIe SmartNick card look like. So one of the purposes is to offload, right? As a SmartNick, you can offload a lot of functions from the main compute. And basically Stingray is also an ARM SoC. So it has actually the A72 3 gig cores, very capable SoC, right? So it can offload quite a few things. As an example, they have shown there. You can do packet processing, crypto, RAID, EC or dedupe, a lot of functionalities that you can offload. And it also can provide the network services, storage services, and compute services in this kind of support. And it fits right into that OpenEDGE server as the SmartNick as well. Okay, so and this is still a concept, right? So there are a couple of possibilities of using this Stingray SmartNick in a 1U, 2U tray. In the 1U tray concept, you could actually use the Stingray SoC as kind of serving both the server and the NIC, right? And it could be built as a kind of an appliances for real-time edge storage or low-power server plus SmartNick. On the right-hand side is a 2U server tray where you could have some sort of a host CPU, and it can support two different SmartNic devices there. And it's intended for some sort of a high-density server with virtual network functions and packet processing and security. So again, these are the different kinds of usage model fitting into the OpenEDGE. It doesn't have to be the compute host CPU, right? It could also be the SmartNiC. So as a call to action, so we would like to have collaboration between ARM partners and the OpenEDGE community to cover a few things to make sure that ARM support is in all the OpenEDGE server specifications. And so I'm just pointing to a few URLs that are covering the OpenEDGE project, as well as the Akraino Radio Edge Cloud blueprint. So for this talk, I was only kind of focusing on one area. There are also a lot of opportunities. I'm sure as time goes, we will make sure all the scenarios can be supported. So with that, any questions? I hope I can answer because I wasn't the one prepared for the slides, but I'm here to present. Yeah, if not, I think Shannon will give you some more thoughts on the Ampere way of doing the OpenEDGE.
Okay, thank you, Don.
Thank you.